The question is that we are given two variables, A equals 6.54 and B equals 123. Both of them are two three significant figures. So those three digits, we're told it's been effectively rounded to that number. Calculate the upper and lower bounds for each of the following, give your answer to three significant figures. All right, so whenever you operate on rounded numbers, that rounding tends to expand as you do operations, and we want to know, well, how far is it expanding? The first thing we need to identify is, well, what are the upper and lower bounds for variable A and variable B? So to do that, we know three significant figures. Uh, it, it would have come, well, any number that is got more digits than those three digits gets rounded to 3, which means that for A, anything that's greater than or equal to 6.535 and anything that's less than 6.545 will be rounded to A. So effectively, when we're told the digit that we're significant to, it's plus or minus one more, the next digit to 5. So for A, it would be plus or minus 0.005. That's another way that you can work out the upper and lower bounds. For B, B has to be greater than or equal to 122.5, and it's going to be less than 123.5, which is good. So now we can start working on the problem. Part A says, what is the upper and lower bounds for A plus B? So let's write down A plus B and work out, well, what's it going to be greater than or equal to? What's the smallest possible value that A plus B could equal? And so we look at the values for A and B. Well, the smallest possible value when you add them together is going to be, well, let's find the two smallest values for A, the one for A, one for B, add them together. And of course, that's just the lower bounds. So you're welcome to grab your calculator, punch in the two lowest values, add them together, and we'll get 129. Let's round it to three significant figures ourselves. And so we're going to do the same thing for the upper boundary. Let's add those two together, and it will be 130, rounded to three significant figures. It told us to give our answer in three significant figures. A times B, and we do exactly the same thing, right? AB, what's it going to be greater than, what, or n equal to? What's it going to be less than? Well, to find, when you're multiplying numbers, to find out the smallest possible value, you want to multiply the smallest possible numbers together. And so we look at the two lower bounds again, and we say, let's multiply them together on the calculator, and we'll find the lower boundary for A times B. And so the lower boundary, after we multiply them together, is 801, rounded to three significant figures. And the upper boundary is going to be 808. Okay, those were, I guess, the easier ones. Once we get to C, we're now doing A divided by B. And A divided by B, we now have to ask ourselves, well, how do we get the smallest boundary in that operation of division? And the answer may be a little surprising, is, well, let's take the smallest number of A, because that's going to help us get to the smallest number. And let's divide it by the largest number of B that we can have, because if you divide it by the largest number, it's going to get smaller and smaller, right? So the larger you divide something by, the smaller the answer gets. And so that's what we're going to do. So let's take the lower bound of A, 6.535, and divide it by the upper bound of B, 123.5. And we'll have our lower bound for the division, which is 0.0529. And of course, that's rounded to three significant figures. The upper boundary is like, we want the largest possible division that we can get. So we need the largest possible value of A. And we're going to divide it by the smallest possible value of B, because that's going to give us a larger number. If we divide it by a larger number, the answer is going to get smaller and smaller and smaller. So we want to divide it by the smallest possible number. And that's going to give us 0.0534, rounded to three significant figures, of course. And the final part, where it's getting more and more complicated each one, is we're trying to do b minus 1 on a. I recommend that we break this up into two segments, or well, two stages. It may be easier to work out what's happening. And the first one is 1 on a. Let's work out the upper and lower bounds for 1 on a. And so we ask, what happens when you invert a number? What happens when you have a small number and you do 1 over a small number? And what happens when you have a large number and you do 1 over a large number? Well, when the number's fairly small and you do 1 over it, it gets large. And the larger a number is, so say for example, 2, 1 over 2 is a half. And when I say large, relatively speaking, right? And so that was 2 is a small number and it turned into a half. But let's consider 100, because 100 is a lot larger than 2. What happens when you do 1 over, or 1 divided by 100? You get 1 over 100, which is small. 1 out of 100, that's 0.01, and 2 is 0.5, and of course a half is much larger than the 1/100th. Which tells me that the upper bound is going to be when I take the 1 over the smallest number, and the lower bound is when I got to take 1 over the largest number for A. And so we work that out. They're actually going to, it looks like they're swapping places. The lower bound for 1 on A is 1 over 6.545, which turns into, rounded to 3 decimal places, 0.153. And the upper bound for the inverse of A, which is 1 on A, is 0.153 as well. Okay, so we've got a small problem because it looks like they're exactly the same when they're rounded to 3 decimal places, but that means I'm going to store those numbers in my calculator as variables. So when I do an operation, I'm using the whole number that it is equal to, and I'm not rounding early when I do my operation. All right, so now we are trying to do b minus 1 on a. We have the upper and lower bounds for 1 on a. They're actually in our calculator. And when we subtract, how do we get the smaller boundary? Well, to get the smaller boundary, you take the smallest value of the first operand, which is b. And so we're going to take the lower bound of b, and we're going to subtract the largest value of a. So we're going to subtract the upper boundary of, well, it's not a, it's 1 on a. And we subtract that from the lower boundary of b. That ends up giving us 122 rounded to 3 significant figures. And to find the larger boundary for b minus 1 on a, we're going to take the larger boundary for b, which is the upper boundary, and we're going to subtract as little as possible. So we're going to subtract the smaller boundary, or the lower boundary, for 1 on a. And that is the larger boundary, 123.5, excuse me, minus 0. And I'm going to use the number stored in my calculator for that. And I get 123 rounded to 3 significant figures. And so my job is done.